Hey guys, so here's an example of the SailCat problem, the first SailCat that I ever made. A cat is sitting on a counter and spots a housefly buzzing 5 feet above it, taking care to calculate its trajectory just right and setting up for success with the appropriate number of butt wiggles. The cat leaps into the air, its height modeled by this function, where t represent time in seconds and h is height. Obviously, it says it right there. Sketch the scenario. So I used to have a big white space here, and that was for when this was an actual worksheet where people can sketch. Now, if you think about how cats jump, obviously they go up and then they come back down, which is an inverted parabola. We know that because this lead coefficient is negative, that this will be an upside down or a downward facing parabola. We also know that because of the 16 here, we're talking about gravity in terms of feet per second. If it was negative 4.9, it would be gravity in terms of meters per second. So there's that. All right, so first question, how high was the counter from which the cat leapt? Well, I mean, we just talked about this in the other video. The y-intercept is the c term. So that's really all that we needed to start with there. So the counter was 4 feet high. Okay. Did the cat reach the appropriate height to snag the housefly? Explain. So first off, the cat needed to reach a height of at least 9 feet to get the fly because it was sitting on the 4-foot counter, and we're just going to assume that the cat's height is negligible here. But the housefly was 5 feet above the cat. So it was at least 9 feet off of the floor is where the housefly was. So did it get there? I don't know. Now we need to use our negative b over 2a. So negative b, the b term is positive 16. And so that's negative 16 because negative b over 2a. And so the a term is negative 16. So 2 times negative 16. And then that is negative 16 over negative 32. So negative 16 over negative 32. And that is positive 1/2. Okay. So then that just tells us the time, because is the cat only going to get 1/2 foot off the ground? Like, not off the counter, off the ground. Because this is all of the height, the elevation, in terms of its relationship to the ground. So this is just the time aspect. The x value is the time aspect. So we need to plug that back in. And so what we're going to do is we're going to take this right here, and we are going to substitute in 1/2 for each t. And it's very important to remember dang it, I did it again. The order of operations, that the only thing that is being squared is the 1/2, not the negative 16 times 1/2 squared. It's 1/2 squared. And 1/2 times 1/2 is 1/4, and 1/4 of negative 16 is negative 4. And then here, 16 times 1/2 is 8, and then 4. And so those two 4s are going to cancel out. That's so nice. And so the elevation is 8 feet. The cat won't win. When did the cat reach the floor in triumph or defeat? All right, so this one, I'm going to tell you, is not factorable. Why is that important? Because reaching the floor means the x-intercept when its height is 0. And so the x-intercept is going to be where this equals 0. So we're going to solve these just like we did last week. Now I will tell you these are not, or this one is not factorable. I'm not sure about all the ones on the SailCat problems that we're going to be doing this week, but there's not very many of them that involve the reaching the floor. So we'll get there whenever we get there. Okay, so with this one, what I would do is plug it into the quadratic formula. Now, I'm going to be very honest with you. I just re-recorded this video because the first time I did it, it was 12 minutes long, and I'm trying to not make them incredibly long. So I'm not going to do the quadratic formula. I'm going to cheat and take it over here to Desmos because I can. No, not because I can, because of time reasons. And so what we're looking for are the x-intercepts, and we see that there are two of them here. This one says negative 0.207, and what that means is at negative 0.207 seconds, the cat's on the floor. And it's like, no, it's not. It's been sitting on the counter doing its butt wiggle thing. Because for, a fifth of a second, it's still going to be butt wiggling. It was not on the floor. This is the mathematical interpretation. Where real life starts to happen is here at time 0. And so this is an unrealistic route. This one over here, at 1 1/5 seconds approximately, the cat will be back on the floor. And so the cat will land at about 1.207 seconds. All right, and that we would have gotten with the quadratic formula, because it is not factorable. This is an irrational root. Okay. Do I care if you use the graphing calculator? Yes, a little bit, because I want you to find the vertex using mathematics. I want you to interpret the initial value using mathematics. And I know that the quadratic formula can be cumbersome. But, I mean, if that's the part where you use the Desmos graphing calculator, I don't feel so bad. But honestly, I would rather you be comfortable with the quadratic formula. All right, last thing real quick. Good. All right, last thing real quick is, sorry about that. Well, dang. Oh, right, sorry, other tab. Here we go. Last thing is the problem that you have for today. Rocket Cat is go for launch. Its height can be modeled by this function. What is the maximum height that Rocket Cat will achieve, and when will it achieve that height? And so this obviously is talking about the vertex. The deal is you got to know which one of them is the x value and which one is the y value, and that's pretty much all I got. So I'm going to get off of here, and you guys go have fun with Rocket Cat. See you tomorrow.